Hello everyone and welcome back to my channel. In today's video, I'm going to solve JEE Mains 2019, 8th April Shift 1. Thank you very much for the constant feedback through comments and emails, and I have tried to respond to each and every one of you and tried to include all the questions and concepts that I have been asked for. So these are the questions that we are going to solve in today's video. So the first one that we are going to solve is from the chapter of integration. I haven't included integration much in my previous videos, so today I am going to solve this one. The second question is from the chapter of differential equations. I know that there would be a question or two in JEE Mains every year regarding differential equations, so this topic is really important as well. The third question that we are going to solve today is from functions and integration. JEE Mains always has these cross-topic questions, and these are really important. The next question we are going to solve today is from conics, and then we have probability. Again, probability, a really important chapter for JEE Mains in advanced both. And then we are also going to solve permutations and combinations. I always feel that probability and permutations and combinations go hand in hand, so always try to include a question from these two chapters. Then we'll do limits. Limits is also really important as far as JEE Mains, advanced, and even your board exams are considered. Then we'll have one question today from trigonometric equations. I know I haven't had any trigonometric equations before, so today I have included this question. Then one from sequence and series. Then one from application of derivatives. I haven't included any application of derivatives, so this is from that chapter. And the last question we'll do is from quadratic equations. So these are the questions that we are going to solve today. Let's begin. Integral of sine phi x over 2 over x over 2 dx is equal to, and we have some options. So let's try to solve the integral. And let me just list the trigonometric identity. We know that sine of 2x is 2 times sine x times cosine x. We can use this thing. So sine of x can be written as 2 times sine of x over 2 times cosine of x over 2. So we know that we have sine x over 2 in the denominator, and we can multiply and divide by the same. So here we have sine 5x over 2 sine x over 2. We need a cosine x over 2. So we'll multiply by cosine x over 2 as well. And we also need a 2 in the denominator, so we'll put a 2 in the numerator as well. Now if we simplify this thing, we'll have 2 times sine of phi x over 2 times cosine x over 2, and the denominator is sine of x. Now looking at the numerator, we know that this is one of the sine a plus b kind of functions, and I'll again list this. So we know that sine a plus sine b equals to 2 times sine a plus b over 2 cosine a minus b over 2. And if we look closely at the numerator, then a and b for our equation will be 5x, 3x and 2x. So the numerator becomes a sine of 3x plus sine of 2x over sine x dx. So if we plug in 3x and 2x in place of a plus b, then we get 2 times sine 3x plus 2x is 5x by 2 times cosine 3x minus 2x is x by 2, which is exactly our numerator. So a is 3x, b is 2x. So remembering these trigonometric identities is really useful. Then again, using the trigonometric identity, sine of 3x is 3 times sine of x minus 4 sine cubed x plus 2 sine x cosine x. This term is for sine 3x and this term is for sine 2x divided by sine x dx. Now we divide by sine x and our question becomes really simple. You have 3 minus 4 sine squared x plus 2 cosine x dx. Now we know that sine squared x is 1 minus cosine 2x. Again, remembering these trigonometric identities is really important for integration and differentiation. So we substitute this by 1 minus cosine 2x instead of the sine squared x plus 2 cosine x dx. So we are left with 3 minus, this is 1 minus cosine 2x by 2. So now we have 3 minus 2 plus 2 cosine 2x plus 2 cosine x dx. So solving this integral, we know it's 1 plus 2 cosine 2x plus 2 cosine x dx, and now we can just integrate these terms. Integration of 1 is x. This is 2 times cosine 2x is sine 2x over 2 plus 2 times sine x plus c, which is x plus sine 2x plus 2 sine x plus c, which is our answer. Let's look at the options. And this is option number 4, x plus 2 sine x plus sine 2x plus c. Let's move on to the next one. Let y equal to y of x be the solution of the differential equation x squared plus 1 whole squared dy by dx plus 2x times x squared plus 1 times y equals to 1 such that y of 0 equals 0. If under root a times y of 1 equals to pi over 32, then the value of a is. So we have this differential equation x squared plus 1 squared times dy by dx plus 2x times x squared plus 1 times y equals to 1. First thing we do is divide by the term x squared plus 1 whole square. So we are left with dy by dx plus 2x times x squared plus 1 over x squared plus 1 squared times y equals to 1 over x squared plus 1 whole square. So we are left with dy by dx plus 2x over x squared plus 1 times y equals to 1 over x squared plus 1 whole square. And this equation is of the form dy by dx plus py equals to q. We know this is one of the linear differential equations and we can solve this by finding the integrating factor. So the integrating factor is equal to e integral of this term. So that is 2x over x squared plus 1 dx, which is 1 plus x squared. Let me just solve this thing real quick because this is e to the, if we had substituted x squared plus 1 as t, then we know 2x dx is dt. So this thing becomes, the integral of this thing becomes log of x squared plus 1, and e to the log would cancel out, so that would be x squared plus 1. And now the solution of this integration, this differential equation is y times the integrating factor, which is x squared plus 1, times the integration of this term q, 1 over x squared plus 1 squared, times the integrating factor dx. So we are left with y times x squared plus 1 times, we are left with 1 over 1 plus x squared dx, and we know that 1 over 1 plus x squared dx, the integral of this thing is tan inverse x. So we know the solution is y times x squared plus 1 equals to tan inverse x plus c. Here we don't have a multiplication, we have an equal to, my bad. And we are given that y of 0 equals 0. So we can easily find out the value of c. So over here, plugging in 0, we are left with y. Tan inverse 0 is 0 plus c, and y of 0 is 0, so 0 equals c. We know the value of c. Plugging in x equals to 0 and y equals to 0. So we know that the solution is 1 times 1 plus x squared equals to tan inverse x. Now let's try to find y of 1. So plugging in x equals to 1, we have y times 2 equals to tan inverse 1, and tan inverse 1 is pi over 4. So 2y equals to pi over 4. So y equals to pi over 8. And we are given that under root y times y of 1 equals to pi over 32. So using this thing, we will get under root a as 1 over 4. So a is 1 over 16, which is option 3. Let's move on to the next one. If fx equals to 2 minus x cosine x over 2 plus x cosine x and g of x equals to log x, where x is greater than 0, then the value of the integral from negative pi over 4 to positive pi over 4 g of f of x dx is. So we know that g of x equals to log x and f of x equals to 2 minus x cosine x over 2 plus x cosine x. So what should g of f of x be? This thing would simply be log, instead of x, we plug in this whole f of x. So we have log 2 minus x cosine x over 2 plus x cosine x. So we know we need to find the integral from negative pi over 4 to positive pi over 4 log of 2 minus x cosine x over 2 plus x cosine x dx. If we look closely at this integral, we know that we should remember this property log of a over b equals to negative log b over a, because log a over b is log a minus log b, and this is minus log b minus log a, which becomes log a minus log b. This is a very important identity for logarithms. Applying this thing, we know that this thing is negative log 2 plus x cosine x over 2 minus x cosine x. If we add these two equations, equation 1 and equation 2, then we are left with 2 times the integral is equal to, it's 0, because these two terms, so this thing would be minus pi over 4 till pi over 4 log of 2 minus x cosine x over 2 plus x cosine x, and we have negative log of this term, so which means that we can divide this, and dividing this we multiply by the inverse, which is 2 plus x cosine x over 2 minus x cosine x dx. So this thing becomes pi by 4 log of 1 dx, and log of 1 is 0, so the integral is 0. Let's look at the options. It would be log of 1, since log of 1 is 0. Let's move on to the next one. The shortest distance between the line y equals to x and the curve y squared equals to x minus 2 is. Let's try to plot the curve. So this is our Cartesian plane, and the line y equals to x passes through the origin. Pardon me for the drawing. Something like this. And the curve y squared equals to x minus 2 looks something like this, with the vertex at 2, 0. And this is the line y equals to x. Now, we have this one small concept from the application of derivatives, that the point on the parabola that is shortest to the line, if it was something like this over here, then the tangent and this line would be parallel. The drawing is not so clear, but this is a concept from application of derivatives, and if you want to know the proof, please let me know. I can even show you that, but we don't have enough time here to show the whole proof. So the tangent at that point should be parallel to this line, then only the point is nearest to the line. So by using this concept, we know that for the line y equals to x, slope equals 1. So for this point Q, we know that the slope of the tangent should be equal to 1. So let's differentiate, find dy by dx. So for the parabola y squared equals to x minus 2, we have 2 times y, dy by dx equals to 1. So dy by dx equals to 1 over 2y. So we know 1 over 2y equals 1, which means y equals half. We know y equals to half. Let's plug in into the equation of the curve. So we have 1 by 4 equals to x minus 2. X is 2 minus 1 over 4. 2 plus 1 over 4. So x is 9 over 4. So the point Q that we have is 9 over 4, comma 1 half. And the shortest distance would be this point, and the perpendicular dropped onto that line, and this point. This would be the shortest distance between the line and the parabola. We don't need to find the point on the line. To find the shortest distance, we just need to find the length of the perpendicular, which can be done easily. 9 by 4 minus 1 by 2 over under root 2, which is 7 over 4 under root 2, which is option 1. Let's move on to the next question. Let A and B be two non-null events such that A is a subset of B, then which of the following statements is always correct? So we know that A is the subset of B, and we also know that A is not equal to B. So the probability of A given B is written as probability A intersection B over probability of B. And if we had like a universal set like this, then the probability of B would be this, and there is some event A such that the probability of A is this small shaded region inside of B. And this is because of this information that A is a subset of B. So using this information, we know that the probability of A intersection B is equals to probability of A. So we can say that the probability of A given B is probability of A over probability of B. Now let's look at the options. Clearly we know it's not option 1 because probability of A given B is not probability of B minus probability of A. One thing to note is probability of B is between 0 and 1 inclusive. So we know that we are dividing the probability of A by a number smaller than 1. So we can say this thing as probability of A given B is always greater than or equal to probability of A. So the second option satisfies this condition. The third option is not clearly true because probability of A given B is not equal to 1. And the fourth option is the opposite of what we get. So the answer is option 2, probability of A given B is greater than or equal to the probability of A. Let's move on to the next question. All possible numbers are formed using the digits 1, 1, 2, 2, 2, 2, 3, 4, 4 taken all at a time. Then the number of such numbers in which the odd digits occupy even places is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let this be a 9-digit number, and the even spots would be this, 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 and this. So we have 4 even spots and 5 odd spots. If we look at the digits, then 1 and 3 are the only odd digits. So we have 1 is repeated 2 times and 3 is repeated 1 time. So we know that we have only 3 possible odd digits, but we need to fill out 4 places. So the first thing is from these 4 spaces which are even represented by a dot underneath it, we need to select 3 spots where these digits can lie. So the total number of ways of selecting 3 spots is 4, choose 3. From 4 we are choosing 3. And in these 3 spots, we need to put these 3 odd digits. So the ways of doing that is 3 factorial, and the multiplicity of 1 is 2. So we divide by 2 factorial. This is the number of ways of placing the odd digits in even places. Now, in the remaining 6 places, we need to arrange the even digits. So we have 6 spots remaining. So that is 6 factorial ways of doing it divided by, we know that the multiplicity of 2 is 4. So we divide by 4 factorial, and multiplicity of 4 is 2. So that is dividing by 2 factorial. And solving this comes up to be 180. So our answer is option 1, 180. Let's move on to the next question. Limit sine squared x over under root 2 minus under root 1 plus cosine x equals. So we have limit x approaching 0 sine squared x over under root 2 minus under root 1 plus cosine x. First thing we do when we see under roots in the denominator is rationalize. This is generally a very good technique. Excuse me, this would be plus, and 2 plus under root 1 plus cosine x. So we are left with sine squared x times under root 2 plus under root 1 plus cosine x over, this is 2 minus 1 plus cosine x. So we have limit x approaching 0 sine squared x times under root 2 plus under root 1 plus cosine x over 1 minus cosine x. Now again, remembering our trigonometric identities, 1 minus cosine of x is 2 times sine squared x over 2. Let's use this identity. So we have limit x approaching 0 sine squared x times under root 2 plus under root 1 plus cosine x over 2 times sine squared x by 2. We know one thing, that limit x approaching 0 sine a of x over ax equals to 1. So we know we have a sine squared x in the numerator and sine squared x by 2 in the denominator. So let's try to multiply and divide by some numbers to get this kind of limit. So we have limit x approaching 0 sine squared x over x squared. We have 1/2 here because the 2 should go here. So sine squared x by x squared is taken care of. And we need an x squared in the numerator. We have under root 2 plus under root 1 plus cosine x in the numerator. Now let's take a look at the denominator. So we have sine squared x by 2. So we divide by x squared by 4 and multiply by x squared by 4. So now the limits having sine squared are 1. So we are left with 1 by 2 times x squared times 4 over x squared times under root 2 plus under root 1 plus cosine x. And cosine of 0 is 1. So plugging in these values, we are left with half times 4 times 2 root 2. So we are left with 4 root 2, which is our answer, which is option 3. Let's move on to the next question. If cos alpha plus beta equals to 3 by 5, sine alpha minus beta is 5 by 13, and alpha is greater than 0 and beta is less than pi by 4, then tan of 2 alpha equals. So we know cos of alpha plus beta is 3 by 5 and sine of alpha minus beta is 5 by 13. So if we had a triangle representation of these angles, this angle will be sine alpha plus beta. So this will be 3, this will be 5, this would be 3, and this would be 4. And same for alpha minus beta. This would be 5, this would be 13, and this would be 12. So from these triangles, tan of alpha plus beta is the perpendicular over the base, which is 4 by 3. And from the triangle with alpha minus beta, it would be 5 by 12. And tan of 2 alpha can be written as tan of alpha plus beta plus alpha minus beta. Again, using the trigonometric identity, tan of alpha, let me use some other term instead of alpha. So tan of x plus y is tan of x plus tan of y over 1 minus tan x tan y. Using this identity, tan of 2 alpha would be tan of alpha plus beta plus tan of alpha minus beta over 1 minus tan of alpha plus beta times tan of alpha minus beta. Plugging in the values that we found, it is 4 by 3 plus 5 by 12 over 1 minus 4 by 3 into 5 by 12, which gives us 63 over 16. So the answer is option 2, 63 over 16. Let's move on to the next question. The sum of the series 2 times 20 choose 0 plus 5 times 20 choose 1, so and so till 62 times 20 choose 20 is equal to. This is a very classic example in series. And the trick that we do here is write the sequence here. So it's 2 times 20 choose 0 plus 5 times 20 choose 1, so and so till 62 times 20 choose 20. And we write the sequence in the other way. So we do 62 times 20 choose 20 plus this would be 59 times 20 choose 19, so and so 20, and we have 2 times 20 choose 0. Now we know that 20 choose 0 is equals to 20 choose 20, and 20 choose 1 is same as 20 choose 19, so and so. So we know that the terms that are multiplied are same. So here it becomes 64 times 20 choose 0 plus 64 times 20 choose 1, so and so. And here we have 64 times 20 choose 20. So 64 can be factored out. We are left with 20 choose 0 plus 20 choose 1, so and so 20 choose 20. And we know that the sum of this thing is 2 to the power 20. So the sum of the whole sequence is 64 times 2 to the power 20. And here actually this thing is 2 times the sum of the sequence because we are adding this equation 1 and equation 2. So this is 2 times the sequence. We know that 64 can be written as 2 to the power 6. So 2 times the sum of the sequence is 2 to the power 6 times 2 to the power 20, which is 2 to the power 26. So this sum of the sequence is 2 to the power 25, which is option 2. Let's move on to the next question. If S1 and S2 are respectively the sets of local minimum and local maximum points of the function fx equals to 9 times x to the 4 plus 12x cubed minus 36x squared plus 25, where x belongs to real numbers, then. So we have the function 9x to the 4 plus 12x to the 3 minus 36x squared plus 25. Let's differentiate it. So we are left with 36x cubed plus 36x squared minus 72x. We can factor this out. We have 36x x squared plus x minus 2, which can be written as 36x times x plus 2 times x minus 1. This is a topic from the chapter application of derivatives, and the way we solve this is we draw a number line, mark the roots of this equation, so it should be minus 2, 0 and 1, and we see the values in these intervals, which means the intervals we'll investigate are negative infinity to negative 2, from negative 2 to 0, from 0 to 1, and from 1 to infinity. So for all the values less than negative 2, the value of the derivative would be negative. Between negative 2 and 0, it would be positive. Between 0 and 1, again, it will be negative. And for greater than 1, it will be positive. And you can plug in just some arbitrary value. So maybe from this, you plug in minus 5. From this interval, you plug in minus 1. From this interval, just plug in 1/2. And from this interval, plug in 2. If you plug in these values, you will get the sign of the derivative of f. So we know when the derivative, and this is for the derivative of f of x. When the derivative changes from negative to positive, we know that this is a minima. When it changes from positive to negative, this thing would be a maxima, and similarly, this thing would also be a minima. And we are given that S1 is a set of the local minima, so S1 has negative 2, 1, and S2 is the set of maxima, So S2 contains 0. So our answer is option 3. Let's move on to the next question. If alpha and beta be the roots of the equation x squared minus 2x plus 2 equals to 0, then the least value of n for which alpha by beta to the n is equal to 1 is. So we have this equation x squared minus 2x plus 2 equals to 0. So we can write this as x squared minus 2x plus 1 equals to negative 1. We know that this thing is the formula of x minus 1 whole squared. So we know that x minus 1 whole squared equals to negative 1 is iota. So the roots of this would be 1 plus iota and 1 minus iota. So let's say that alpha equals to 1 plus iota and beta equals to 1 minus iota. Then the value alpha by beta would be 1 plus iota over 1 minus iota. Whenever we have complex numbers in denominator, we rationalize. So multiplying and dividing by 1 plus iota, we are left with 1 plus iota square over 2, which is 1 plus iota squared plus 2 iota over 2. And 1 plus iota squared is 0. So we have 2 iota over 2, which is iota. So we know that alpha, the ratio alpha over beta is iota. And we also know one thing, that iota to the 4 is 1. Iota to the 8 is also 1. So basically iota to the 4n equals 1. So, and we need to find the value of n such that alpha by beta to the n equals to 1. So n would be 4, 8, 12 and so on. And the least value would be n equals to 4. So our answer is option 3, 4. So that's it for me from me today. Thank you very much for watching the video. Please do like, share and subscribe to never miss a notification. Please comment with any feedback or suggestion, or you can also email me at paste.solver@gmail.com. Thank you very much for watching.